What do you think space sounds like? That's a question that's been asked by scientists. People have always wanted to know what's beyond their experience, what lies beyond the horizon of their knowledge. What if I told you the cosmos is full of symphonies, of creaks and groans, hisses and hums, roars and whistles? And most astonishingly, that all around us every second of every day, there's music of the spheres, the grand opera of the universe being played out in every direction. We just can't hear it. If you were born without hearing, you wouldn't know what you're missing. But what if you were born without sight? In that case, you'd still know what you're missing because there's so much more to life than sound alone. You'd see a world of color, light and shadow play out all around you. But then again, you wouldn't see radio waves or infrared radiation, ultraviolet rays, X-rays and gamma rays. Nor would you know what it's like to feel the sun's warmth on your skin, which is also part of the electromagnetic spectrum. Your eyes can only see a tiny band of this spectrum, a small slice of the electromagnetic pie. You are truly missing out on a feast. But perhaps you're thinking this is a bit of poetic license, a stretch too far. After all, the things you can see are very real. You can touch them, walk among them. The invisible, well, that's by definition unseen. So how can we possibly say that what we cannot see is really there? Well, let's go back to sound. Your ears pick up vibrations in the air around you and translate them into something your brain can understand. But what you can hear is just a tiny range of frequencies. Your lower limit is about 20 Hz, which gives rise to the deepest bass notes, and your upper limit is around 20 kHz, giving rise to the highest treble. Anything above that and you're basically going deaf. Below 20 Hz and you might feel the rumble in your bones, but you won't hear anything. Also, your ears need a certain range of frequencies to work at all. If you lived somewhere where their pressure was hundreds of times greater or less than here on Earth, you'd be utterly deaf. So in a sense, what we call silence is a lie. Everywhere around you, all the time, there are sounds both high and low, fast and slow, that you're completely oblivious to. And this brings us to the stunning realization that our auditory experience is not just restricted by our biology, it's restricted by our location too. Here on Earth, sure, we might notice a bird tweeting or a baby crying, a guitar playing or thunder clapping, a jet flying overhead or the wind rustling through the trees. But all the time all around us, there are sounds that we simply can't detect, can't interpret, because they're not what we're used to. They're too high or too low, too fast or too slow. This shouldn't be all that surprising. Here we are on one little planet in an unfathomably vast universe. It's arrogant in the extreme to assume that what we happen to be able to hear is all there is to hearing. Don't forget, there's a whole lot more to the electromagnetic spectrum than what we can see. This is basically a cosmic orchestra tuning up and we're standing right in the middle of it, blissfully unaware of 9/10 of the music. All around us, stars are flaring up, pulsars are winking, quasars are quaking, black holes are roaring, neutron stars are whizzing, galaxies are grinding, colliding and groaning. Even in the closest reaches of space, the din would be deafening. Fortunately for us, that noise isn't all in our heads. It's real, just as real as the sunrise, the moon in the sky, the seasons of the year and the flow of time. We just can't hear it. That's why scientists use radio telescopes, infrared cameras, and ultraviolet detectors to study the universe. They're listening into the sounds that we can't. There are many ways of converting these signals into something we can actually hear, a process called sonification. It's not possible to translate everything all at once. Our brains would simply short-circuit, but by isolating particular frequencies, we can make sense of the music of the spheres. Radio waves emitted by pulsars can be translated into sound. These are highly magnetized rotating neutron stars that emit beams of electromagnetic radiation from their poles. As these beams sweep across space, it's like a lighthouse sweeping a beam across the darkness, except instead of light, it's radio waves, and instead of keeping time with a regular pulse, they blink with an uncanny regularity. Scientists can identify these radio wave pulses and translate them into sound. The result is a series of clicks. Sometimes these clicks are regular, sometimes random. But always they are utterly alien. These sounds that we can't hear are so common throughout the universe, they're practically ubiquitous. In fact, it's fair to say that space is absolutely teeming with them. Galaxies produce radio waves as hot gas in their colossal cores gets all fizzy and makes massive jets shoot out into the darkness. These leave long wisps of radio energy in their wake. When this energy hits our radio telescopes, we can translate it into sound. The result is a kind of eerie whistle. Black holes are another great source of these sounds we can't hear. And their emissions are even stranger than those of galaxies. Black holes are surrounded by accretion disks, clouds of superheated matter spiraling into the abyss. And as this happens, they emit huge bursts of X-rays. Now, these X-rays can be converted into sound. But the real mystery here is that the sound isn't constant. It's often irregular and sometimes even periodic. And no one's exactly sure what causes this, although it's likely to be related to the chaotic nature of the accretion disk itself. But the most astonishing thing is that these irregular and sometimes periodic signals are coming from all over the universe. Not just in our galaxy, not just near our solar system, but from billions and billions of light years away. Across the immensity of space, black holes are hissing and groaning in unison. They're whispering the same secrets, telling the same tales of cosmic creation and destruction. And these are just two examples of the myriad ways that stars and planets and galaxies and black holes and neutron stars make these incredible sounds that we simply can't hear. Stellar flares can make popping sounds. Planetary magnetospheres can make humming sounds. The hum of the Big Bang's afterglow, that's a sound too. In fact, that's a symphony, an entire concerto, played out across the entirety of space, a divine composition that's older than the universe itself. Every single star produces its own unique song, a stellar lullaby that cradles nascent planets and bids them goodnight. Each has its own particular chemical fingerprint, its own mass and gravity, temperature, luminosity and magnetic field. All of these factors come together to produce a sound that's as unique as a fingerprint. The only trouble is, like most songs, these sounds aren't easy to decipher. It takes time and patience and an expert ear to translate them properly. Take Saturn, for instance. Our Voyager probes detected strange radio emissions coming from the planet's orbit around the Sun. These emissions could be translated into sound, and the result was haunting, almost otherworldly. Then there's Jupiter, which emits a sound that's been dubbed Jupiter's Scream. It comes from the planet's powerful magnetic field, which funnels particles of plasma down towards its colossal red spot. As these particles accelerate, they emit electromagnetic radiation, which we can detect and translate. The result is a high-pitched whine. It's almost impossible to imagine such a cacophony, a chorus of cosmic proportions, taking place all around us. The sheer volume of it, the variety, the sheer alienness of it all. How can we possibly hope to understand it? Well, it's already been happening. For millions of years, scientists have been sifting through data from radio telescopes and translating these signals into sound. Some of them are incredibly beautiful, others unnerving, some make the hairs on the back of your neck stand up. Others just sound plain weird. And these are just the ones that have made it to Earth. We're just beginning to scratch the surface of the sounds that our universe has to offer. And yet already we've heard enough to know that we're missing out on a cosmic oratorio, a grand opera that's playing out all around us every second of every day. It's a shame we can't hear it, but maybe that's for the best. Imagine trying to hold a conversation with someone when there's a black hole screaming in your ear. As Carl Sagan said, "We are made of star stuff, born in the furnace of our sun, shaped by the dust of exploded stars." It seems fitting that we should listen to the music of the spheres and try to understand the language of the cosmos. What secrets will it reveal to us? What mysteries will it unlock? Who knows? All we can do is listen and marvel at the wonders of the universe. So now it's time for you to join the conversation. What other hidden aspects of the universe do you wonder about? What do you want to know? What do you want to see? Ask your questions and we'll find the answers. Together we'll explore the unknown and bring the hidden into the light. Join us and see what we can discover together.